we're going to go back and take a look at how to long divide numbers. And then we're going to look at how that same process, or how the process is very similar for long dividing polynomials. Now, it's been a while, I'm sure, since you've done long division. So to remind you, we first look here and we see how many times it goes into, and then we match the number of digits. So 2 digits goes into 2 digits, and then if it doesn't go into that one at all, then you extend out to more digits. So 43 goes into 51 once, and then remember that we do 43 times 1, which in this case is 43, and then we subtract it. So if we do 51 minus the 43, then that gives us 8. Right? And then we bring all these numbers down. So then I do that same thing where I'm comparing, okay, well, how many times does 43 go into 86? Well, it goes in twice. So we do 2 times 43 gives us 86. Then we subtract, and then we bring down our numbers. So then we've got 82. Well, 43 goes into 82 one time. So we do 1 times 43, which is 43. And then we subtract. So then here you have to borrow. So then this is 12 minus 3, which gives us 9, and 7 minus 4, which gives us 3, so we get 39. Now, there's a couple things that you can do from here. You would write remainder 39, or you would do 121 and 39/43, right? So you would take your remainder and then divide it by what your divisor was. This thing is your divisor. Or you would keep going. So you'd put a decimal and then bring down your 0 and then say, okay, well, 43 goes into 390. And then you would see how many times 43 goes into it. So it goes into it 9 times. So then you would do point, and then you would do 9 times 43. So if you do 9 times 43, then that gives you 387. And then you'd subtract, and you bring down another 0, and you could either keep going with that process until you got to a certain number of decimal points or until it ended. Okay? We're going to be using this idea here. Okay, so our remainder is written as a fraction. Now, our process is very, very similar. So when we have our long division with polynomials, there's a couple things that you need to do. First of all, both the divisor, so the thing you're dividing by, and the dividend need to be in descending order. Or standard form. Okay? So if we look here, this thing is our dividend. Okay? And then this is our divisor. So both of these need to be in descending order. This one's already in descending order because we have squared and then none. Remember, the divisor is the thing that goes on the outside. So we're going to have 3x squared minus 2 on the outside. And then the dividend, this thing is the one that goes underneath. But I need it in descending order. So this is not descending order. It's exactly backwards of descending order. So we go cubed, squared, 1, none. So we're going to write 6x cubed minus 12x squared minus 5x plus 4. Now, for some of you, you may want to, and I'm going to call this 1a, put in zeros for missing powers. Okay. So here on this one, this is really 3x squared plus 0x minus 2. So depending on how apt you are at making random errors, or how quick you go and make random errors because you're trying to go quick, I would maybe suggest if you're somebody that makes little errors like that, that you put in this 0. So the first thing that you're going to do is like what we did over here. So you're going to see how many 43s go into the first 2. And you're only caring about the first 2. So on this one, we're only caring about the first term to the first term. Okay? Now, instead of saying how many go into this one, it's easier to think off to the side, what's 6x cubed divided by 3x squared? Okay, so this is like our thinking step. So if we do 6x cubed divided by 3x squared, 2 of the x's cancel out with 2 of the x's on the bottom, and then this reduces to 2 over 1. So then we get 2x. So I'm going to put the 2x on top here, which notice is what we did with the 1. 43 goes into 53 once. Then we distribute, or we multiply. So we multiplied the 1 by 43 here, so we're going to multiply the 2x by each part. Really, we were multiplying the 1 by 3 to get to 3 and the 1 by 4 to get to 4. So here we're distributing each part. So I multiply here to here, here to here, here to here. So if you leave the 0, well, I guess I'll do the first step first. So 2x times 3x squared gives us 6x cubed. Okay. Now when you do this, this should match. If it doesn't match, that means you did something wrong. Okay. Now if you drop the 0 and you're not putting the 0 here, you would just be doing 2x times negative 2. What most of you would be likely to do, don't write this part down right now, is that you would do minus 4x. But notice here that this is not lined up with something that's a like term. So some of you would be apt to add those together on the next step when they're not like terms. So what you can do is avoid that error by putting in this 0 so that you get the 2x times by 0x is 0x squared. And then you do the 2x times the negative 2, which is negative 4x. Okay? The other way that you can do it is just make sure that you line up the correct terms together. So if I don't have that 0, I can see, okay, well, this is just an x, so it lines up with this one. Okay? Now, here we had subtracted. Okay? When we're subtracting, we were really changing the sign and then adding the two of them, but you didn't know about negative numbers or changing signs yet, so we just called it subtract, which is essentially the same thing. So I'm going to change the sign of all of these. Okay. Then I change the sign, and then I'm going to add straight down. So these get added, these get added, these get added, and then I'm going to bring that down just like we brought down these other numbers. Okay. So we multiplied. I changed the sign, so that's a little different than what you had learned because you were just subtracting, or you can think subtract off this whole polynomial, which means you'd have to distribute the negative. Both of those are fine. So if we do 6x cubed minus 6x cubed, that gives us no x cubed, which is what we want. And then 12x squared minus no x squared is negative 12x squared minus no x squared is negative 12x squared. And then we have negative 5x plus 4x, which gives us negative x, and then we're just going to bring down the 4. Okay? So this you don't actually have to write, the 0x cubed part, because that's just nothing. So then all you're doing is repeating that same process that we just did. So now I'm going to look at this first term divided by this first term. So off to the side, we're really thinking negative 12x squared divided by 3x squared. Well, that gives us negative 4 because the x squareds cancel, right? So then I get negative 4 up here, and I'm going to multiply to all 3 parts, or 2 parts, depending on how you're doing it. So then I do negative 4 times 3x squared is negative 12x squared, excuse me. And then negative 4 times 0x is 0x, technically negative 0x. And then negative 4 times negative 2 is a negative 8. Then you have to remember to change your signs. I always like to either grab a different colored pen or pencil and actually change the sign into a different colored pen or pencil, just like I have on here. That way when I go back and check work, then I know which was the original sign. It's faster to check the work, essentially. So here, I'm going to add these two. Those go to 0, which is great. That's what I want. So negative x plus nothing is negative x. And then we've got 4 plus 8. Oh, I misdid my sign. Negative 4 times negative 2 is a positive 8. So then when we change our sign, this goes to a negative. So then 4 minus 8 gives us negative 4. Okay. Now, once this power here is lower than this power, okay, so this is an unsaid 1. Once that power is lower, that means that's your remainder. Okay. So this is my whole thing is my remainder here. So I'm going to put that up here. And remember, we're writing it as a fraction. So we're going to do our remainder, which is negative x minus 4 over what we divided by. Our dividing by is the 3x squared minus 2. I don't have to include the 0 there, so this will be plus the remainder, which is negative x minus 4 over 3x squared minus 2. So our process is very, very similar. You have to make sure your polynomials are in standard form. Then you're going to compare first term into first term. So you're thinking 6x cubed divided by 3x squared. You put this number up top. You multiply all three. Then you change the sign, add straight down. Then you restart that process over and over and over again until you get to the remainder. So then I'm going to do first term divided by first term, which gives us negative 4. Put that up top, multiply all three, change the sign, add straight down. And then as you're going along, you're checking to see, is this power lower? Well, this power is lower. The other way that you might catch it if you just go on autopilot is if you do the first term divided by the first term. So here, notice I would have one of these x's cancels with one of those, so I would get negative 1 over 3x, right? So if your x is on the bottom, then that means you're at the remainder part. So then I don't do this part. Okay? So then this whole thing is our answer. Okay? Now, let me show you another example. Okay? So here we've got this one. Okay? So I need them in descending order. So I look 4, 3, 1, none. They're in descending order, 2, 1. So they're in descending order. So I'm just going to do 3x squared minus 2x into 6x to the 4th plus 5x cubed plus 3x minus 5. So we're going to take the first term into the first term. So I'm thinking off to the side. You don't have to write this each time, but just so you can see my thinking process. We're thinking 6x to the 4th divided by 3x squared. So then that gives us 2x squared. Now some teachers will be really specific and make you put this thing over where the x squared is in this one. So this one we're missing our x squared. So again, some of you may want to do plus 0x squared, and then it was the 3x minus 5. Okay. Depending on how fast you go or how prone you are to making little errors. Okay. So I'm going to do 2x squared. So some teachers force you to put it over this one. I don't actually care where it's located on the top. That doesn't bother me. So we're going to do 2x squared times 3x squared. So then that gives us 6x to the 4th. I do a quick check that matches this one. That means I've done everything correct so far. 2x squared times negative 2x gives us negative 4x cubed. And then I'm going to change the signs. Don't forget about changing the signs. It's obviously very important. Then we're going to add straight down. This goes to nothing, as it should. So then I get 5 plus 4 gives us 9x cubed. I'm going to keep the 0x squared plus 3x minus 5. So then I'm going to repeat that same process again. So this divided by this. Right? Now you also could potentially have plus a 0 here, right? It's also a possibility. So then you would have plus 0x squared here. Okay. So then you're going to do 9x cubed divided by 3x squared. So then this gives us 3x. So I'm going to put the 3x on top. And then I'm going to distribute to each one of these. So then we get 3x times 3x squared is 9x cubed. 3x times negative 2 is negative 6x squared. Now this will be where maybe some of you would have a problem. If you don't have this 0 here, it would be lining up with the 3x. So some of you would be apt to add those two things together. So this is why it's sometimes advantageous for you to put the 0x squareds or put in placeholders for your zeros. So then the 3x, okay, so then that's our last one, or you can do your next placeholder of 0. So then you just have plus 0x. So then you change the signs, which is important. So I change the sign, change the sign, change the sign, and then I add straight down. So that gives me nothing, which I should be anticipating. This gives me 6x squared plus 3x, because 3x minus nothing is 3x, and then minus 5. So I'm going to look. This power is matching, so it's not lower, so I need to go again. So then I'm going to do 6x squared divided by 3x squared. So that gives me 2. So I'm going to do plus 2. Then I'm going to distribute to each one of these. Okay? And you may or may not have this placeholder 0. And you may or may not have this placeholder 0 here. On this step, it won't matter because it would have gone to this 3. So 2 times 3x squared gives us 6x squared. 2 times negative 2 is negative 4x. And then 2 times the 0, if you're going to put it, is 0. I change the signs. So I get negative, positive, negative. And then I add straight down. So this goes to nothing, which is what we're anticipating. This gives us 7x. And then negative 5 minus nothing is just negative 5. I check my power here. This is an unsaid 1, which is lower than a 2. So then this is my remainder. So then I have my answer as 2x squared plus 3x plus 2 plus the remainder, which is 7x minus 5, all over what we divided by, which is 3x squared minus 2x. So then this whole thing is our answer. Okay? So it's all about repeating that same process. So you look and see inside first term divided by outside first term. Put that up top, multiply by everything, change the signs, add straight down. Then you repeat. So inside term divided by outside term, put it up top, multiply, change the signs, add straight down. Then you keep repeating until you get to a power that's lower, and that's your remainder.